All right, for these first few graphs, I'm just going to talk through them because this is actually kind of from last chapter. How do we graph quadratics just based off of transformations? So if we're given a quadratic and we can see the transformations, then we don't have to worry about finding a vertex formula and all of that stuff. We can just graph like normal. So I just want to go through 11b. We have a horizontal dilation by a factor of 1/3. Every x gets divided by 3. Every y is left alone. And then you're going to shift up 1. So I'm taking these original points, applying the 1/3 x to them, and then shifting them all up 1. For 11c, which is this red one down here, 11c, there's a 1/3 on the x. So every x is divided by 1/3, which means you really have a horizontal dilation by a factor of 3. Dividing 1 by 1/3 is the same as multiplying by 3. So horizontal stretch. Every y value is left alone. So here's me taking these points and multiplying the x values, by 3. And then after I do that, the -3 right here is a shift of down 3. So I just sketched these graphs for this assignment. I didn't have my graph paper ready to go. For 12b, we're dividing every x by 1/2, which is a horizontal dilation, a stretch, by a factor of 2. And so you can see again, I took these original quadratic points and multiplied all the x's by 2. And then after that, we're going right 1, down 3. For part C, every y value is multiplied by -1/2. So I did that here. And then we should be going left to down 1. Sorry. Yeah, when you multiply by -1/2, that's both an x-axis reflection and a vertical shrink, a dilation by a factor of 1/2. So that graph should be opening down. And finally, for part D, every x value gets divided by 2, and then we go left and up. So x divided by 2 changes all of these points, and then left and up. So you should have a skinnier parabola because this is a horizontal shrink by a factor of 1/2. So that's all really what we did last chapter. I just wanted to remind you that these transformations still exist. And sometimes if we're graphing quadratics, we'll just use transformations. The new stuff from the beginning of this chapter from our notes is what if we don't have something in its transformation form, meaning we can't see how this has been shifted. So we're supposed to write the quadratic in standard form, which is vertex form, and sketch the graph, identify the vertex, axis of symmetry. So for the first two, I decided to do this with complete the square. And then for my last 3, I think, I'm using the vertex formula. You can pick your favorite. I don't care whether you complete the square or use the vertex formula. You won't be required to do one method over the other for any of our AP problems or just in general, so it's fine. Okay, so say I'm going to do complete the square for number 13. To complete the square, we put x squared minus 6x in parentheses. The complete the square formula is that in the parentheses, you're adding b divided by 2 squared, and then you're doing the opposite of that on the outside of parentheses. So b is -6, divided by 2 is -3, squared is 9. So if I have a +9, I need to turn around and subtract 9, do the opposite of that. That way, we're keeping this equation the same. We've just added 0 to the equation. So this makes f of x equal to x minus 3 squared minus 9. So complete the square creates that perfect square trinomial. Now I can see the vertex is at 3, -9. I kept my graph on here just so that the video is not super long. So over 3, down 9. The axis of symmetry is just what is this vertical line that you don't have to graph, but what is the line that cuts this parabola in half? It's x equals 3. Make sure you have x equals. It's an equation. And the x-intercepts, I could maybe get them from graphing. It looks like they land right on the axis. Or I could say, when is f of x equal to 0? This I can factor in x out, and then x equals 0 and x equals 6. Those are the two x-intercepts. You could also solve it from your vertex form. You could say, I'm going to add 9. I'm going to square root both sides. Remember your plus or minus in that case. And then you're going to add 3 to this side. So positive 3 plus or minus 3 comes out to 6 and 0. All right, I think factoring is faster, but if the problem doesn't factor, then you could go from your vertex form. Now, number 15, if you're given a trinomial, don't jump right into the vertex formula or complete the square. Check to see if this is a perfect square trinomial, then you can get it in vertex form right away. This is x minus 4 times x minus 4. So it's x minus 4 squared. So that's my vertex form. And then I can see that the vertex is 4, 0. The axis of symmetry is x equals 4. If you graph this thing, this is just a parabola that's been moved to the right 4 units, so you can graph a bunch of points there. And the vertex is the x-intercept here, so the x-intercept is x equals 4, or I should probably be writing these as ordered pairs. Go back and do that for the last one. All right. I'm going to switch to the vertex formula. I could complete the square on this, but I think vertex formula is more efficient. So if I had a choice between the two methods, I usually choose vertex formula. So to calculate the hk of the vertex, you start with h. You're starting with the input. The formula is negative b over 2a. We did derive this in our notes. The reason for that is it's just taking complete the square and turning it into a formula. So anyway, negative b would be positive 6 over 2 times a, which is 1. So the input for the vertex is 3. The output is what you get when you plug 3 in. So this is 9 minus 18 plus 2. Okay, so I get a vertex of 3, negative 7. And then I need to still write the directions are still write the vertex form of the equation. So the coefficient in front of x was 1, in front of x squared was 1. So I keep that the same. And then vertex form is x minus 3 squared minus 7. The axis of symmetry is x equals 3. What about the x-intercepts? I can't factor the original f of x. So I'm going to set my vertex form equation equal to 0. We're doing quadratic formula tomorrow, so you could do quadratic formula on this. I just haven't officially talked about it yet, so just showing you all of your options. You would isolate the squared portion, so add 7 to the right side, square root both sides, which makes this x minus 3 equals plus or minus radical 7. I'm not putting absolute values around x minus 3 because the plus or minus takes care of that. Otherwise, it'd be this. And then you would say x minus 3 could be plus or minus radical 7. Okay, so you don't actually have to write that. Anyway, solving for this, we add 3. I always put the number out in front, add 3 plus or minus radical 7. Those are the x-intercepts. They're not nice points, you can see from the graph. So they're decimals. It's like 3 plus or minus 2 point something. Right? For 22, I'll do the vertex formula again. So h is going to be opposite of b, negative 3, over 2 times a, which is 1. So we're going to get a fraction here. We just have to be careful on our math. So we're squaring negative 3 over 2. That's 9 over 4. 3 times negative 3 over 2 is minus 9 over 2, plus 1 over 4. Working with fractions, you need them all to have the same denominator. So I'm going to change 9 over 2 to 18 over 4. 9 minus 18 is negative 9, plus 1 is negative 8. over 4, which is actually negative 2. So the vertex is at negative 3 over 2, negative 2. When I write my f of x, the number in front of x squared is 1, so I can not have anything out in front of parentheses. X plus 3 over 2 squared minus 2. F of x equals that, sorry. Axis of symmetry, x equals negative 3 over 2. We're also supposed to find the zeros. Okay, so the zeros, because I can't factor the original and I haven't talked about quadratic formula yet, I would be setting this equation equal to 0. Add 2 to the other side. Square root both sides. Remember the plus or minus. And subtract 3 over 2. Negative 3 over 2 plus or minus radical 2 equals x. Those are the x-intercepts that hit there and there. Okay, what about word problems or other application problems? So these are actually kind of shorter. For 37, we're supposed to write the standard form, the vertex form of the quadratic whose graph is a parabola with the indicated vertex, and it has to pass through the given point. Use a graphing utility to verify. I'm not going to do that, but here's our basic outline, excuse me, for vertex form or standard form of a quadratic. When they give you the vertex for 37, they're giving you h and k. So you can fill into this formula. H is 1 and k is negative 2. When they give you the point that has to be on the parabola, that's a general xy. X is negative 1. Y is 14. So the only unknown out of all of these variables is a. We don't know what the vertical dilation is on this problem. But we're about to find out. So we can add 2 to the other side. Negative 2 squared is 4. Divide by 4. And then the final answer is, now that you know a, you can go back and write the vertex form of the equation. Y equals 4 times x minus 1 squared minus 2. This has the vertex we need, and it has the correct a that will make sure that the point negative 114 is on the graph. Same thing for number 40. So again, we start out with our outline for standard form or vertex form of a quadratic. We're given h as negative 1/4, so this is going to say plus 1/4. Excuse me. K is negative 1. The point xy, x is 0, and y is negative 17 over 16, and we don't know a. Add 1 to the other side. Adding 1 is like adding 16 over 16 since I have fractions. 1/4 squared is 1/16. Over here we've got negative 1/16 equals a times 1/16. So a is negative 1. So the equation is y equals negative, parentheses, x plus 1/4 squared minus 1. All right, now in 57 and 58, the directions for this problem are at the bottom of the page, so I've just kind of copied them over here. Find the two positive real numbers with the indicated sum whose product is a maximum. Product is a maximum, meaning we're going to be looking for a vertex or a relative maximum if we were to graph all the products. 57. The sum of the first number and twice the second number is 24. So for 57, the sum of the first number and twice the second number is 54. Make sure no, not 54, sorry. It's 24. I was going to say, make sure I wrote down the right numbers. Okay, we're looking for a maximum product. So this is how the two numbers relate to each other. Let's just call it P for product. The product of these two numbers, the two numbers are x and y, is just x times y. So now if I take this equation and say solve it for x, because that would be easy to do, I can say instead of the product being x times y, I can say it's x times I can replace x with 24 minus 2y times y. And if I look at this as 24y minus 2y squared, this is my formula for all of the products that could be on the made out of these two numbers. So what this is saying is you've got some sort of parabola. I don't really know how it's shifted. You've got some sort of parabola that opens down. We're looking for the vertex of all of these products, and they're based off of inputs of y. So vertex, I don't really want to complete the square. I'd rather just do the formula. Find h and k. Negative 24 over 2 times negative 2. Negative 24 over negative 4 is 6. Okay, so we get, now do we need to find k actually? Let's look at this. The vertex is yp, right? All these ordered pairs are yp. So I just figured out that the maximum product is when y equals 6. Do I care what the maximum product is? Not really. I know that y equals 6. So now I just want to go back and figure out, well, what's x? X is 24 minus 2 times y. So x is 12. So the maximum product is with numbers 6 and 12. If you do the whole vertex, the value you get for the k coordinate is just what is the maximum product. 6 times 12 will be the maximum product, 72. All right, let's set up the same thing for 58. For 58, it says the sum of the first and 3 times the second is 42. So the sum of the first and 3 times the second is 42. We're still looking for which two numbers that have this relationship make a maximum product. So again, I can say, well, let's solve this equation for x. X equals 42 minus 3y. So now my product equation is 42 minus 3y times y, also known as 42y minus 3y squared. I want the vertex. I at least want the input of the vertex. Negative 42 over 2 times negative 3. Negative 42 divided by negative 6 is 7. So the vertex, again, represents a y and a product. So we just figured out the vertex is at 7. So y equals 7. X equals 42 minus 3 times 7. 42 minus 21 is 21. So max product when the numbers are 7 and 21. All right, that's it for this homework assignment. Please come into office hours if you have questions on any of these problems.